Hello, algebra students. Mr. Lawrence here, and Lainey asked about trying to remember how to write a function from a given set of data. Remember the different types of functions we can come up with. We can come up with a linear function, okay, and then there's a quadratic, and then of course cubic and quartic. I'm not going to do all of these, but we'll talk about how to do them. I'll do some of them, and of course there's exponential, okay. Now, it's all about the differences. Remember, linear is when the first difference is constant. First difference is constant. When it's like plus 2, plus 2, plus 2, you're going to take that 2x and then try to manipulate that into a function, right? That matches the data. Quadratic, it's all about the second difference. When the second difference is the same, okay, then you're going to have some kind of quadratic system going on. Cubic is when the third difference is the same, and then quartic is the fourth difference, okay? All right, now exponential is when the differences are actually being, they're multiples. The differences are multiples. Differences are being multiplied, okay? And of course, linear, might look like f of x equals 2x minus 4, right? Quadratic might look, g of x equals x squared plus 1, something like that. Exponential would look like f of x equals maybe 3 to the power x and then plus 1, something like that. Okay, so let's do a couple examples here. So I've got 3 examples ready to go. And here's the first one. Remember, first thing we do is we make a little table, right? And so those are our f of x numbers. This is a very crude table. I apologize. All right. And I need to move that one out of my way here. Let's put that up there. And then I need my x and my f of x, right? All right, and I got 1, 2, 3, 4, 5. Where did I get those numbers from? Because this is the first term in the sequence, second term, third term, fourth term, fifth term. Okay, and then I'm looking for the nth term, right? Okay, so I go to find the first differences. Well, it looks like I'm taking away 3. Looks like I'm taking away 3 every time. That means my function is going to be some form of negative 3 times whatever n is. So now I do my comparison line. Remember that comparison line, Lainey? Right? So 1 times negative 3 is negative 3. 2 times negative 3 is negative 6. Negative 9, negative 12, and then negative 15. Now I compare and see, how do I turn the blue ones into the black ones? Well, to do this one, I would have to add 9. I would have to add 9. I would have to add 9. So the nth term is going to be negative 3n plus 9. My function would be f of x equals negative 3x plus 9. And I use, I'm sorry, that should be n and then f of n. Sorry about that. Because I used x here, I'm going to use x there. So there's my function, which it's linear, right? It should be becoming familiar, or becoming re-familiar. All right, let's do the second one here. Same thing, gonna make my little table. Okay, I need that. And I'm gonna erase this. And then we're gonna have our n terms and our f of n terms, right? And 1, 2, 3, 4, 5. And so what is the actual nth term? Well, I'll go looking for differences. So the first difference is plus 3, then plus 5, then plus 7, then plus, is there a mistake there? Let me see something here. Yeah, I think I have a mistake in this one. Hold on a second. Let me regenerate it, and yeah, something's not quite right. So hold on one second. I think that's right. Maybe I'm just thinking wrong. Plus 3, plus 5, plus 7, and 24. Oh, yeah. I'm okay. Plus 9. All right. Sorry about that. Fooled myself for a second. Now, the first differences don't match, so I'll go down to the second differences. And look at that. They're always plus 2. Since their second differences are already the same, this is some type of n squared pattern. Now, remember, it's kind of a subtle point, the coefficient on n squared is half of this number. So if you want to put a 1n squared, you can. All right? So if I square 1, I get 1, and then 4, and then 9, and 16, and then 25. And now I'm going to compare up. How do I turn the blue ones into the black ones? Well, it'll be minus 1. Minus 1. 4 minus 1 is 3. 9 minus 1 is 8. It's minus 1. So the nth term is going to be n squared, or 1n squared, minus 1. So my function f of x is going to equal x squared minus 1. And that's quadratic. All right. If I'd gone down to the third difference, it would be cubic. Fourth difference would be quartic, etc. Here's one more. And then we'll call it a wrap on this video. So maybe this will be easier instead of drawing them all the time. Let's see here. Can I infinitely clone him? Yeah, it's taking me about the same amount of time, but that's okay. All right, so here we go. All right. So we're going to have n and f of n. First term, second term, third term, fourth term, fifth term. And we're looking for the actual nth term. So let's go find our differences here. Looks like I'm adding 3, and then I'm adding 5, and I'm adding 9. I wonder if I have a mistake here. Yeah, that's 6. That should be a 5, shouldn't it? Yeah. No. That is a 6. Sorry about that. That's a 6. Yeah, that's not a 37. There we go. There's a mistake. I knew there was a mistake in there somewhere. Sorry about that. This should be a 30. Okay, so this will be plus 10. Ooh, something's really bothering me here. You know what? Give me a second here. Talk amongst yourselves. I'm going to make sure I have this right. Okay. 2, 3, 4, 5. 2, 1, 3. There's a mistake. Okay, 16, 15, 32, 33. Okay, this better. I'm sorry about that, ladies and gentlemen. I really don't want to remake the video, so I'm going to start again. Okay, so we're going to change these numbers here. And when we do that, oh, come on, eraser. All right, there we go. Okay, so we're going to change the numbers, because I must have goofed somewhere. And we're going to put 1 and 3, and then 7, and then 15, and then 31. Okay, and this might look familiar to some of you. All right, so we're going to go first difference plus 2, plus 4, plus 8, plus 16. Do you notice that the differences are doubling? If you don't, you can do it again. You go plus 2, plus 4, plus 8. They continue to repeat. If I gave you the sixth term, there would be a plus 16 here. And it would go on then 32 and then 64. The differences are doubling. Whenever the differences are doubling, it's the number of the multiple, which would be what, times 2, right? So it's 2 to the nth power. Yeah, if they were tripling, it'd be 3 to the nth power. Okay, hopefully that's making sense for you. So it's going to be some type of pattern like 2 to the power of n. And I'm going to go ahead and test them. 2 to the first is 2. 2 to the second is 4, 8, 16, 32. And then how do I adjust these blue ones to turn them into the black ones? Looks like I'm taking away 1 every time. So the nth term will be 2 to the power n minus 1. So the function would be f of x equals 2 to the power x minus 1, and this would be exponential, right? Exponential. All right, that's it for the video. Hopefully I didn't screw you up too bad with that pattern there. I apologize for that. If you need some more help with that, let me know. Mr. Lawrence signing off. Have a good night, everybody.